All right, so here we go. Right now we're going to talk about multiplying radicals. Now, I didn't show you the rules on the last page, but the biggest thing you need to remember, when we are multiplying radicals, we're going to multiply the numbers under the radical together and the numbers on the outside together. And then the last thing you always will do is simplify. You always want to multiply together first because it might cut down and it makes it a little easier. So let's look at example 1. I have radical 6 times radical 8. Now, if we look, when we see this problem, we have 6 and 8 are both under the radicals. So when I multiply 6 times 8, I know I get radical 48. Now, we look at 48 and we think about it. Is this a perfect square? And we know that it's not a perfect square. Again, I put the note card on the left side of the screen. So if I come over here, 48's not here. But I know it would be right here between 36 and 49. So if I start working my way up, I think of factors: 36, 25, 16, 9, 4, 1. That can go into 48. And I know I can use 16. And I can also use 4. Again, try to always use the biggest perfect square. If you can't remember these facts, use 4 and keep breaking it down until it can't be simplified. So I know most of us probably forget about 16 and 3, so we would use 4 and 12. So if you look up here, I know I can do 4 times 12, which gives me 48. I know I can take the square root of 4, and when I take the square root of that, that goes to the outside. So now I'm left with 2 radical 12. But again, we need to think about it. Can I break down radical 12 anymore? And again, we know 12 is not a perfect square, but is 9 a factor? Is 4? I know 4 is a factor, so now I know I can also do 2 radical 4 times 3. So again, I know I can take the square root of 4, which again comes to the outside, and now I have 2 times 2 on the outside, which in turn turns to 4 radical 3. And we look, and the number underneath the radicals is simplified as it can go, so we are done. All right, let's look at 2. I've got radical 3 times radical 15. Again, I don't have numbers on the outside of the radical, so I'm just going to multiply the 2 numbers underneath together. And I have 3 times 15, which gives me radical 45. Now we look, is 45 a perfect square? When we look at our note card, we see it's not, so we've got to break it down. And we know we can do 9 times 5. We know we can take the square root of 9, so our answer is 3 radical 5. We know we can't break down 5 anymore, so that's our final answer. Now, the first 2 examples we looked at were just very simple. The numbers underneath, that's all we are given. But when we look at example 3, I've got negative 4 radical 15 times negative radical 6. Now, again, inside times inside, outside times outside. So again, first of all, I know there's that 1 between that negative and the radical 6. So the first thing we're going to do is we're going to multiply the negative 4 and the negative 1. Both those numbers are on the outside. Again, like variable terms, radicals, if there's nothing in front of it, there's that invisible 1. So negative 4 times negative 1 is 4. And now we multiply the numbers underneath together. And we know 15 times 6 would be 90. Now, we know 90 is not a perfect square. We got to break it down. We all know that we can do 4. We leave the 4 on the outside, and we can just do 9 times 10. we know we can take the square root of 9, which is 3. That comes to the outside. Again, when you have numbers on the outside that you need to combine together, you are just going to multiply. That means that 9 is going to go away. So I have 12 radical 10. Now we think about 10. 10's not a perfect square, but can we break it down more? We know the factors are 1 and 10, 2 and 5. We know none of those are perfect squares, so our final answer would be 12 radical 10. Now, let's look at ones like number 3. It's a distributive property, but again, you're going to combine it the same way. You're going to take the term, the radical on the outside, or the number on the outside, and multiply it by both terms. Final thing is you might have to start combining your adding and subtracting. So, if we look at number 4, I've got 3 radical 5 times the quantity of 6 minus 2 radical 6. So we know we can't combine our terms on the inside because this doesn't have a radical attached to it. But I know I can take the 3 radical 5 and distribute it to each term on the inside. So if I first look, I've got 3 radical 5 times 6. 3 radical 5 has that radical 5. The 6 is just plain. That's an outside. So 3 times 6 is 18. And then that radical 5 just gets brought over. Now, we've done the first one. We can't break down radical 5 anymore. So now let's look. So now I have 3 radical 5 times negative 2 radical 6. So again, we're going to go 3 times negative 2, and I'm going to get plus 6 radical. And then I go 5 times 6, which is 30. So now this is turned into an addition problem. When I look at this, I have the 5 and the 30. They aren't the same numbers underneath the radical. I know I can't break down radical 5 anymore. Now I need to think of 30. I know my factors for 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. None of those are perfect squares, so I know I cannot simplify 30 down. So that means my final answer is 18 radical 5 plus 6 radical 30. So the biggest things you need to remember when you're working with radicals, when you add and subtract, the number underneath needs to be the same. You leave the numbers under the radical alone. You simplify down if you need to. When you multiply the numbers underneath the radical together, the numbers on the outside together, and then you simplify. The last step you should always do is simplify radicals down. I hope this helps. If you guys need more questions, make sure you ask your teachers. Have a great day.